are in listen-only mode.
Hello, welcome to our Working from Home webinar series. Today we're going to talk about oleophobic surface treatments. Hopefully soon we'll be able to say working from work. My name is Edward Hughes. I'm the CEO of Aculon. I'm joined here today with me is Mara Gattuso, who is a Senior Business Development Manager. From a logistical perspective, a couple of things. Firstly, this webinar will be recorded. We will be sending you an email to basically giving you a link to the recording and also a link to the PowerPoint presentation, so you can download that and share those with your colleagues if they're unable to make it today. As long as you've registered for the webinar, you will be getting that email probably later today. This is also going to be an interactive webinar in that if you have questions, please go to the GoToMeeting question tab, type in the questions, and we'll make sure we leave enough time at the end to try and address as many as we can. So again, thank you for joining us. We hope everybody is well and safe. Obviously, we are through what I call the end of the beginning of this pandemic, and that it's been obviously surprising from the scope, the speed, and the stakes involved in that. We've all learned how to adapt to what is going on, and particularly to a lot of us from working from home. Fortunately for us as a company, Aculon is a specialty chemical company and was deemed as an essential company, which meant that our lab and our production teams have been continued to operate in the building. And now in California, we're starting to bring back the folks that have been working from home, and hopefully that's the same situation for you. But we designed this webinar series to basically be educational and informative, and to let you know that we're there for you when we come out of this, and hopefully we can work together and solve some surface-related challenges that you are having. Our goal as a company is very simple. We enable customers to make better products. We do this by being an innovative, responsive, fast developer and producer of best-in-class surface modification technologies. Our belief is together we create winning products. So let me give you a quick overview of what we're going to cover in the next 30 or so minutes. I'm going to give you a little overview of Aculon. Some of you may not be familiar with us. I'll talk a bit about some of our technology platforms, some of the different surface modification options that we have. But today we're really going to focus in on oleophobic applications. We'll explain what that means. We'll explain some of the testing. And then I'll give you some examples from some of the fields that we work in, electronics, oil and gas, specialty markets. And then I will talk a little bit how we work with our customers so we can basically help you achieve your goals through our lab services. And then we'll dive into the questions. So as I say, if you have questions, please type them in. We will address them at the end of the presentation. But if you see something in a slide that provokes a question, please type it in and we'll try and address it as best as we can. As a company, Aculon is involved in many different fields. You can see from this collage of images, we're involved in specialty markets, medical devices, oil and gas, electronics, industrial applications, consumer goods markets. We were founded in 2004 with basically the purpose of developing an expertise around surface modification. So we develop and we produce surface solutions to modify a broad variety of surfaces, whether it's metals, glass, polymers. We functionalize those surfaces by basically creating hydrophobic or super hydrophobic, oleophobic, which is the focus for today, hydrophilic anti-fingerprinting, or even adhesion promotion. Our treatments all are thin. They are easy to apply. We don't use any vacuum deposition equipment, often no cure. They're safe, they're non-toxic, and we offer green options as well. We like to think that as a company, we differentiate ourselves not only by developing proprietary innovative treatments, but also our willingness to work with our customers to solve their problems. We spend a lot of time trying to understand what it is you are trying to achieve and the parameters which you need to make this be successful. And then we will recommend potentially customized products to help you solve those problems. We're organized into three kind of business segments: electronics, oil and gas, and specialty, which includes medical and other industrial applications. Our business model is predominantly to produce chemistry. We work with companies to basically qualify the chemistry in, and then we ship the chemistry to either to their company or to their contract manufacturer so that it can be applied in a manufacturing situation. We do also, in some cases, treat some parts here. If they are lower volume, specialty, or very complex things, then sometimes it's easier for us just to treat the parts here. But the vast majority of our business is regarding producing chemistry and shipping that chemistry. We have a significant IP portfolio, over 35 patents. We've worked on thousands of applications, invested hundreds of thousands of hours building up this expertise. We have over 100 products. Our people are smart, numerous chemists, PhDs, master's degrees, electrical and mechanical engineers. We're based here in San Diego, California. This is where our headquarters is, our lab, our manufacturing facilities. We have operations in Shanghai, Singapore, Dallas, Amsterdam, and in Asia we have a pretty big distributed network as well that we utilize. So today we're talking about oleophobicity. So, when is that important? Well, often a lot of repellency technologies focus on hydrophobicity, which is great for repelling water and other types of aqueous solutions. But in many cases, repellency needs to be oleophobic. So, these are the types of things that some of your substrates will see. It could be organic solvents, it could be oils, it could be grease, it could be adhesives, it could be other hydrocarbons. So if you are experiencing failure or issues with your surfaces because they're coming into touch with these kind of materials, that's when you need oleophobic. So why do oleophobic surfaces matter? Well, as I say, it's the interaction with those type of materials on the surfaces that can create problems. So we've developed a series of oleophobic technologies that are designed to address a pretty broad variety of problems. Here's some examples. It could be a functional issue where, due to a liquid behavior on a surface, it could be that cleaning is either time-consuming, it could be expensive, or in some cases it could be impossible. The part is not going to be able to be cleaned. It could be that you've got surface contaminations from greases, fingerprints, for example, that degrades the product's aesthetic behavior. It could be that oil or liquid droplets contaminate and impede optical performance if you have some kind of optical device or a sensor. It could be that you've got adhesive materials that are in contact with this and they're sticking to that surface and you want that surface to stay adhesive free. It could be that you have a surface that's not lubricious enough, or it could be that the wettability of a surface or a powder is not exactly what you are looking for. Or you may need, to basically have some kind of barrier, but a physical barrier to prevent oil or solvent liquid flow is not possible. So those are some of the challenges that we face when our customers explain the problems that they're dealing with and they're looking for a solution. So when we started the company started with a technology related to self-assembled monolayers of phosphonates, SAMPs, as we call it. And the SAMP is a nanoscale treatment that's comprised of a phosphonic acid and a repellent carbon tail. And so as you can see in the schematic here, the phosphonate head group basically bonds into that metal surface, into that surface oxide, creating a covalent bond. And then we can functionalize the tail group to basically repel oils, waters, and that is a treatment that's 2 to 5 nanometers thick, so very thin. And it relies on this hook and tail strategy that allows us to basically hook into the surface oxide, create that strong kind of covalent bond that resists abrasion, is chemically resistant, is thermally stable, and then we can functionalize to whatever surface kind of functionality that we are dealing with. So that's how we started with the technology. And you can see here, from that, we basically have developed many different platforms. And those platforms, have built around polymeric organometallics, transition metal complexes, surface growth polymers, and a number of hydrophilic, oleophilic treatments. So those are kind of the platforms, and we've kind of translated that into a series of expertise and specific customer-related platforms. So everything relates to surface modification. It could be hydrophobic, it could be adhesion promotion, it could be water barrier protection, oleophobic, as we're going to focus on today, it could be particle treatments, anti-fingerprinting, or hydrophilics. So we have a series of platforms that allow us to basically take our technologies and functionalize them to basically solve a customer's issue. So let's talk about oleophobic treatments. So, we've got a number of technologies that can functionalize a variety of substrates. What we are looking to do basically is, with oleophobic, is you're repelling any liquid. It could be oils, it could be water, but you're keeping those surfaces clean. You're keeping whatever's coming in contact away from those surfaces. And we measure oleophobicity having an oil contact angle over 60 degrees. These treatments are optically clear, they're ultra thin, and they don't basically change the surface appearance, which is in many cases is very important, and particularly in consumer products. You're looking for something that basically the aesthetics stay the same. They're flexible. We coat many different substrates, as you can see: metals, glass, ceramics, polymers, and we use them in a pretty broad variety of applications. So when we work with customers, we basically ask a lot of questions relating to the substrate and what that substrate is going to see, and then we basically match our chemistry options to that. So if you're coming to us with a problem on a metal or an oxide containing surface, we have a number of different options that we'll pull from our toolkit to solve that problem. If you're coming to us with a polymeric, i.e. a non-oxide type of surfaces, we also have a number of options we can use for that to solve this oleophobicity issue. Oleophobicity durability is important, and these treatments are chemically robust, and they can withstand a lot of environmental exposure. So, for example, thermal stability, they're thermally stable in ambient air up to 200 to 300 degrees C. They are abrasion resistant. We have treatments that can be basically give strong covalent bonding, which basically are as good as the underlying substrate. And if you don't damage that underlying substrate, then our coating will survive as well. And here's an example of that. This is done. Some testing showing abrasion resistance on stainless steel. And so what we do is we basically treat the stainless steel with the dry wipe. We basically put it on a linear taper abrader and basically abrade that. You can see up to 100,000 cycles. And so what we're doing during that time frame is measuring the oil contact angle. And you can see that in blue, this is an example of one of our oleophobic treatments we use on metal. You can see even after 100,000 abrasion cycles, it starts at 87 degrees contact angle and goes down to 80 degrees. So very stable, good oleophobic performance. In this particular case, we benchmarked this. We were asked to benchmark against a competitive set, which was a vacuum deposition applied. And you can see it starts out at oleophobic. As I said, for us, the benchmark starts at 60 degrees. But you can see fairly quickly it drops off and loses its oleophobicity. So obviously, if you've got a substrate that's going to see abrasion, etc., and you want it to last, picking the right kind of oleophobic treatment is critical. And finally, on durability, chemical stability, we are basically, these are resistant to a big variety of chemicals. If you are dealing with something that's kind of above a pH 10, that can be problematic. And so some of our treatments will break down in those kind of environments. And the other area that we don't have treatments are organic is basically if you're looking for a strong UV stability, that's not really a good fit for our treatments. So I apologize if that's your focus, but generally we're thermally stable, abrasion resistant, great chemical stability. So the application process, as I said, we like to do things that are relatively straightforward and low capital intensity type processes. These are wet chemical processes, so we don't use any deposition equipment or chambers or batch processes, etc. But these can be dipped, they can be sprayed, they can be wiped, they can be dispensed or jet. And what we'll do as we work with customers is basically adapt the formulation to get the right concentrations, make sure the coverage is right and temperature, etc. So we work with customers in the application process to help get that product qualified, and then obviously you can use it in your ongoing process. So let me get into a couple of examples in the different areas we have, and hopefully these will spark some ideas of something that may be of interest to you. In electronics, we have a number of different applications. We have NANOCLEAR, which is the leading stencil coating product. We do a lot in the anti-fingerprinting. We do some in epoxy control and even in some semiconductor test beds. Let me cover some of these. This is a great product that has been out for about 6 years. It's a wipe application. You can see a part A, which basically cleans that surface, gets rid of any surface contamination, and then you apply the part B. So very flexible in terms of the ability to do this. We have spray versions and other dip versions as well. And this particular product is applied to the underside of a stencil, where basically used in the SMT process. So we treat the underside and the aperture walls. And as a result of basically creating this flux repellent film, the dozens and dozens of customers have seen improvements in quality, both higher yields, better transfer effectiveness. They've boosted their productivity because they have less underwiping of that stencil, which takes away from the production yield. They have less downtime also because of paper changes, and as a result, they are saving money. There's less rework. They've got lower paper and solvent consumption. This product we launched back in 2014. Received several awards. This has been a focus of numerous articles, cover articles as well, in electronics publications, where there's case studies, there's talk about the theory behind it, and all kinds of interesting data that's out there. So this has been a very well-established product, and as a result, it's the #1 in its category. It's not just for fine pitch stencils. It basically improves printing on all stencils. We have cost calculators to show you how to calculate the improved quality, boost productivity, and reduce cost. Treats the aperture walls. It's a durable product, and so that's been a great example of in this case we call it flux-ophobic because it's dealing with flux, but essentially it's an oleophobic treatment. Another category is anti-fingerprinting. A lot of products, particularly stainless steel and aluminum type products, the cosmetics matter. The designers have picked those products because they want those to look aesthetically nice, and they don't want oils from people's fingerprints basically mucking up the surface and ruining the beautiful aesthetics they spend all the time doing. So whether it's electronics, appliances, consumer products, what we're looking to do here with our kind of optically clear, easy to apply surface treatments is they provide functionality of not only being easy clean, right? So basically the oils and that type of stuff will bead up, but also they reduce the visibility of those oils. So that's an interesting area we've been doing for the last couple of years, and we've got quite a lot of traction in that space. Another area which is kind of interesting, very specific in electronics, if you're dealing with controlling epoxy and resin, sometimes you basically want to stop the epoxy residue from sticking to bond pads on capacitors. And here's an example on the left-hand side where you can see, without the EC is a epoxy control, so without Aculon epoxy control, you can see in the top photograph, you've got some epoxy on the bond pads. They use sandblasting to remove that, but you can still see there's some epoxy still on the bond pads below. Well, if you treat these capacitors basically with the Aculon epoxy control, you can see before the sandblasting, the epoxy's on it, and afterwards that surface is clean. So that basically again allows you to achieve your goals of basically increasing your yield, better throughput as well. So that's an example of kind of keeping epoxy away. Another one in the electronic space is semiconductor test bins. If you are making chips and you want to test these chips, each of these chips are tested and they have these probes that basically go touch the surface, and basically they are looking as the probe goes onto that surface and they're going into the solder paste or the tin oxide that's there. In this case, you basically want to increase the longevity of these test bins. And the test bins basically get mucked up by essentially tin oxide buildup on these test bins. So if you have an untreated versus a treated one, you can see we can get a 5 times reduction in the amount of tin oxide buildup, which increases the longevity of the pins and reduces the cleaning of those pins, etc. So it's an interesting example again of an oleophobic type application. In a different field, in the oil and gas field, a couple of examples would be anti-fouling. Obviously, you've got a lot of fouling going on when you have hydrocarbons and crude oil coming out, or it could be optical sensors. So in the anti-fouling application, one area I'll just cover is a oil tank sensor. This is essentially, you have a float a stainless steel tube that goes down the center of the sensor of the tank, and you basically have a float that's differentiating between the oil and the water that's in there as the crude is pumped out of the ground. Basically, oil and water separates out. Well, the challenge is that over time, paraffins and asphaltenes build up on the stainless steel sensor and basically give false readings. So it's a very nasty environment that basically you don't, to go in and get a accurate reading, you have to drain that tank. You have to send somebody in a hazmat suit to basically clean that and remove that surface contamination from the stainless steel tank, the stainless steel pipe, and that's expensive and a hazardous thing to do. Well, if you treat the sensor and the stainless steel tube before it goes into the tank, basically you can go from a maintenance schedule of every 3 to 6 months draining and cleaning out that tank to basically 4 or 5 years where you now don't have that buildup. So it's an extremely kind of aggressive environment, crude oil, and obviously one that you need durability. Another example would be oil sensors. This could be a sensor that goes down well, basically, and is looking at what is going on down well. And they use sapphire because it's a pretty aggressive environment, and sapphire is a very hard, durable substrate. But the problem is that those sapphire windows get blocked by oil and other contaminants building up on that sapphire. So in this case, we will treat the sapphire window and basically allow that sensor to function without having to be brought out and cleaned, which obviously is a time-consuming and costly process. In the specialty markets, we do a pretty broad variety of things. I'll just give you a couple of examples. It could be a medical device where you have a drug that you are looking to dispense, and you don't want the material staying in the needle or the syringe, and so basically a oleophobic treatment will ensure the right amount of drug delivery. It could be a electronic device that you want to be cleaned and get greases off it easily. It could be mesh and other screenings, etc., that you need oleophobicity. It could be an industrial application where you are trying to keep adhesives away. Adhesives, obviously, by its very nature, are very sticky materials, and you want them on certain parts of things, but not on other parts. So, by putting an oleophobic coating down, you've basically changed that surface energy. You're able to repel the adhesive or prevent the bonding of that adhesive, and so you've added to the functionality. You've got greater precision in what you are doing. And here we're applying liquid treatments to those metals or the surfaces to avoid basically adhesive getting in the wrong place. This is an example of a consumer product, guitar string. Interesting problem that we were asked a number of years ago by one of the leading string producers. Can you treat guitar strings? And we said, well, they're metal, so yes, but why? Well, it turns out that basically guitar strings, the sound basically degrades with the oils from your fingers. So as you are playing the guitar or plucking the strings, those oils are getting transferred into these guitar strings, which are wound guitar strings around the core, and the oils essentially dampen the sound. So the alternative at the time was essentially to put a much thicker polymer coating on it, and you get a very durable string. But the problem was they don't sound crisp and fresh as a brand new metal wound string. So we were able to basically apply our oleophobic coating in a nanoscale way that had no sound impact on the guitar string, and kept the durability there because now the oils didn't get in and basically dampen the sound. So you basically got the best of both worlds. You got the crisp sound of fresh strings with the durability of a thick polymer coating. So that was been a great project, and so we've functionalized hundreds of thousands of strings over the years. Sometimes we deal with companies that have particles, and they are looking for to modify the surface energy of those particles. And it could be that you want to have hydrophobic or oleophobic properties on those, and so we'll treat those particles in bulk and functionalize those in a way so that they don't stick together, they disperse better. So, it's an interesting kind of application. Let me switch a little bit and talk about how we work with our customers. So our goal is to help our customers and our engineers that we deal with to basically hit their target. That's what we do. So rather than just throwing something over the fence at you and saying, go try this, we like to take a little bit more of a science approach, a little bit more of a dedicated approach to that problem. And we spend a lot of time trying to understand your requirements. Some customers are reluctant to share all the details, but we're trying to help solve this problem for you. So if we can understand what the substrate is going to see, what issues are causing current failures, what performance expectations you want, etc., then we have a much better chance of helping you. So once we understand that, we'll tell you whether we can do some lab services for you, where basically we'll treat some parts, we'll analyze them, we'll characterize them for you, we'll send them back to you, you test them. We get feedback, are we on target, not on target? If we need to optimize something, we'll go through an optimization process. And at the end of that, we've basically selected which of our treatments work the best. We'll give you a recommendation for an application procedure, and that allows you to go to your plant trial. And if we've done our job and we understand what you're looking for, then collectively we'll hit the target. And that's the process. So it's a little bit more involved than just sending samples out and saying good luck, hopefully it works for you. We like to help you go through this process and make sure that we hit the target. A little bit on our IP. We have a really good combination, what I call hard and soft IP. We've got over 35 patents. We've got many trade secrets. We have tested thousands of applications. We've got a great partnership with UC San Diego, just up the road from us here, where we've got access to millions of dollars of equipment if we need to do the type of testing that only a university would have. We've spent hundreds of thousands of hours solving surface problems. We've invested millions of dollars in building capabilities and our expertise. As I said at the start, we understand and we want to be good stewards of the planet as well. Many of our customers are wanting to have sustainable business practices, more environmentally friendly treatments. So we offer those. We obviously offer a number of business practices as well that do that. So we provide VOC exempt options, PFOA free products, eco packaging and waste reduction. We try to be as efficient as possible in terms of transportation, and even we use as much sustainable energy as possible, whether we've retrofitted our headquarters and facilities with over 800 LEDs. So we understand and we want to be good stewards and try and help our customers support their sustainability. So in conclusion, we are a platform technology company that makes products better. We're focused today on oleophobicity. We are surface solutions experts. That's the only thing that we do. And we've got a strong history of working with customers to solve problems. And so we like to do that because obviously we can help you solve your problems and hopefully you'll have a better product. We've developed a broad portfolio of products, including a number of sustainable options. We've developed a good IP base and testing capabilities, and we have great kind of in-house expertise as well. So that's a little bit about us and oleophobicity. So let me open up the question box here and see if I can tackle some questions. And if you haven't sent a question in yet, please type them in. We'll try and tackle as many questions as we can. Okay, and Mario is going to help me out with some of these. He's got some great technical expertise. So first one is, will these coatings function in a vacuum? Have they been tested under vacuum? Mario.
I do not know that we've tested these in a vacuum environment, but a vacuum environment should have no impact on these coatings on the surface. So if the liquid in a vacuum is contacting the surface, the surface should still be oleophobic and repellent to these coatings. The behavior may be different on a case-by-case basis, but they absolutely should function in a vacuum.
Okay. Next one I'll take, which is, can your coatings be applied to textiles, fiber, or fabric? I understand they're not UV resistant, but are they washable? Yes, they can be. So we've done a number of things on that. What we do find is that obviously fabrics and fiber are pretty absorbent. So the usage tends to go up on that. And so it becomes really a real cost question of whether this is economically the right thing to do. So we haven't done a lot on terms of clothing and those ties, that type of stuff, but we can absolutely functionalize it. It just is that, you know, versus putting it on a metal surface or a glass or a polymer, you know, fabrics are pretty absorbent. So it's really a cost equation. All right, Mario, how does Aculon solution will affect a painted surface if I want it to be protected against fingerprints?
That's a great question. So depending on the type of paint or the type of coating will impact which technology we utilize. We have a broad suite of technologies for functionalizing different surfaces, and these technologies are also contained within a variety of solvents. So we can, you know, a paint is essentially a polymeric layer, and we can functionalize polymers. So depending on your paint or coating, will impact which technology we work with. So it's really a great example of why it's important for us to work directly with you. There is not a one size fits all. We really want to understand your surface. We want to understand the exposure conditions, the performance you're looking for, and we'll get you a technology that fits that surface.
Okay, next one's for you, Mario. Can I treat with Aculon the propeller of the mixing and pumping system from soldering wave machine?
So depending on the type of substrate, absolutely. So actually, and not depending on the type of substrate, we can functionalize those. The substrate will impact which technology we go with, so to say. So this definitely sounds like an interesting application. We can help functionalize those parts, and you can see how they impact your process.
And that was from Darren. If you want to email us afterwards, we can get into a little bit more detail. Okay, next question is, how do you achieve uniform thickness with dipping on irregular shapes? So these, depending on the treatment, these are, if you're looking at a metal type treatment, they're very self-limiting treatments. So basically it's a solvent-based treatment, and you know, the solvent evaporates off, and what's left is a monolayer treatment that basically doesn't stick to itself. It just reacts with the oxide layer on that surface, and so you get a very consistent treatment. So we treat a lot of irregular shapes and parts. So the next one I'll give to you, Mario, is the electric resistance of the coating measurable? And this is for the chip test head, for example.
So the electric resistance of the coating is going to depend on which technology. So assuming that you're talking about one of our technologies that would be utilized on metal, no, it would be imperceptible. The coating is 2 nanometers thick. It's really not thick enough to have any measurable impact. Electrons will essentially tunnel through it. So we have coatings that will have 0 impact. Now, if we were looking at a thicker, more traditional style, thicker coating, which we do utilize in some circumstances, there might be an impact, but those are more utilized in more special, rare scenarios. So most likely not.
Okay, next question. Can you comment on very viscous or sticky oils? I know that we've done a lot of work with crude and various types of crude oils, and obviously I talked about a couple of examples where those are repellent. Mara, I'm not sure, do you know any other work on sticky oils?
Yeah, there have definitely been applications we've worked on with sticky oils or sticky adhesives. You know, when you start to get into a very, very viscous material that's, you know, not behaving like a solvent, you're not really looking at it in terms of water contact angles, but more in terms of the ability of that sticky oil or adhesive or resin to actually bond with the surface. And so you'll find that the big impact there is the surface energy is reduced and the affinity of those materials to actually bond and adhere to the surface is significantly reduced.
Okay, next question, is it FDA approved? I know we have a number of substrates that treatments that are approved for food contact, and then we have some others that are approved for medical device, medical tongs, etc. So again, you have to reach out to us. What we've found and learned is that, you know, FDA approval is not just a blanket statement for a treatment, but rather it's an application specific thing. So what we tend to do is we tend to work with our customers. They'll file for the FDA approval for their particular application. We obviously provide under a confidential basis the details that they need to have for that filing. But we have a number of things, whether it's food contact or surgical tongs, etc., where they have been approved. Okay, Mario, I'm going to give you the next one. Can the tin powders be functionalized so that there is no oxide on its surface?
That's an interesting question, and I would definitely need to get somebody involved to answer that accurately. I know that we are actually functionalizing the oxide layer to bond with it, and I don't know if that means the oxide has left or if the oxide is essentially just underneath the coating that we're laying down. So we are either removing the oxide or we're covering it up. I would need to talk to one of our PhD chemists to get you an accurate answer there. So feel free, please reach out, and I'll ask one of the PhD chemists, and we'll get you a good answer on that question.
Okay, next one is, do you have coatings that are both oleophobic and hydrophobic? And the answer is yes. I think, Mario, that if all the oleophobic coatings also provide hydrophobicity as well?
That is correct. So all of our oleophobic coatings provide hydrophobicity. Our hydrophobic coatings do not necessarily provide oleophobicity.
Okay, next one is, will the coatings work with oil-based ferrofluids? Specifically, will the nanoscale ferrous particles have a negative impact on performance? I'm going to throw that one to you, Mario.
We would need to test that. I've not looked at that application before. We can certainly functionalize the surface that those materials are coming into contact and evaluate how they behave. That's easy to do.
Okay, next one's for you, Mario. Have you coated polyimide flex circuits?
Yes, actually working on a few polyimide applications at the moment. We can functionalize polyimide. Reach out to us, let us know what your application is, and we can help.
Okay, next one, can you treat car tire rubber to make it more chemically resistant? I don't know, we've tried that, but do you have any idea, Mario?
I don't think we've tried that. We can certainly treat car tire rubber, whether it meets the desired performance expectations. I need some more details, but that's a good example of something where we'd like to get to know a bit more about the application. So please reach out.
Okay, great. Well, that's all the questions we have. So I want to thank you. We've gone a little bit over on time, so thank you for staying with us for that. I hope this webinar was informative. I hope we can find a way to work together and hopefully solve some problems that you are having. And we very much appreciate the time. Be safe, and we look forward to working with you soon. So thank you for attending the webinar today.